In this video, we're going to continue exploring root cause analysis tools, and in particular, take a look at a technique called process variation analysis, or PVA. It's a spin-off or alternative to the 5Y approach. And so I encourage you, if you haven't had a chance to view the video on 5Y, you'll want to do so. There are a lot of good tips and techniques that we'll be referencing in this video. The specific learning objectives, though, are going to be to describe the PVA approach, in particular, the artifacts that you should bring into this group problem-solving environment, the specific facilitation techniques that you'll want to apply, and then at the end, I'll share a template that can be used for PVA. So process variation analysis is a modified version of the 5Y approach in which we're taking a look at variation inherent in the system. From earlier videos, we talked about how there are 4 big characteristics that we're trying to attack when we're looking at domain-based projects, and they include white space reductions, or the reduction of idle time handoffs in between each step. Rework loops, or the identification of defects or errors in the system and the reduction or elimination of that rework. Visual waste in the system, the classic lean wastes and Tim Woods, and the reduction and elimination of that type of waste. It's the 4th characteristic that we are really concerned about when we are interested in doing PVA. If I have processes with lots of variation, I'm more times than not going to be using the PVA approach. And so to, again, help better understand how it's used, I'm going to draw a picture of a process that has large amounts of variation. All right, in this example, I've got process performance, and I've also identified the upper and lower specification limits, the needs that our customers have. As it stands, this process, there's an awful lot of process performance that's falling outside of spec. Those regions in red are instances in which process performance isn't meeting customer needs. I'm eyeballing it right now, and I'd say about 1/3 of the time the process is performing outside of spec. How do we resolve this in future state? Well, the picture is pretty obvious. We need to reduce that variation or skinny the curve. In future state, our process performance needs to look like that green line. There's still a small amount that's falling outside of spec. It's not about process perfection, but there is a definite reduction of variation that would take place. When I have processes that look like the black line in current state, and we need to get them to the green line in future state, I'm thinking about PVA. So if I'm going to perform a process variation analysis group problem solving event, the same rules for 5Y or any of the root cause analysis techniques apply. There's a couple of preconditions that we'll need to have. We'll definitely have to bring our data on current state. The qualitative data is good, but in this particular technique, I'm really going to be relying on that quant data. In addition to the data, I'm going to need team and subject matter expertise. The other thing that I'm going to bring in for PVA analysis is not just the data sets, the quant data itself, but I'm going to bring in as much of the descriptive statistics that describe this quant data as possible. So this could include things like, so I'm going to bring in things related to central tendency, including mean, median, and mode calculations. I'm also going to be bringing in descriptive statistics that describe the variation. To perform a PVA session, here's what I'll do. I'll bring the team in the room. I'll share with the team the descriptive statistics that are described above the red line. And let's just say that for this particular process phenomena, we have performance that looks something like this. The average is 4 days. We've had some instances that go out to 30 days. We've had a few instances that can be done as quickly as 1 day. Uh, and about, I don't know, 10 or 15% are well over 15 days. This is an example like the handoff that we saw in the complex business problem case that was looked at a little bit earlier. There's the histogram. We know that the mean or the average is 4. We know that the max was just over 30. We know the min was at 1 day. All of this could have actually been captured through standard interview techniques where we ask subject matter experts, what do you feel the average is? Can you give me some examples of some extremely long or quick instances? But you've also got an entire data set that has also shown that this information applies. We could calculate range. That's easy to do. We could also calculate standard deviation in this instance. With this information, I will then begin the following questions. I'll ask the team, if the average is 4 days, what's causing these extreme conditions on the long end of the tail? What's causing it to take up to 30 days? Based upon the data that you've collected, your own experience working in the process, all of the interviewing and direct observation that you've done, we know the average is 4, but it seems as though it can last as long as 30. What's causing this? And at that point, it just becomes a modified 5 why session where the team members list off their responses. We choose the one that appears to be most impactful. And then I ask, well, what's causing that? And we continue to drill down until we've identified root cause. And I encourage you to take a look back at the 5 why video for techniques on facilitating this type of a session and the 3 characteristics that frequently determine when you've hit root cause. Now, sometimes this uniquely painful, extreme maximum incident really was a 1 in 10,000 or a 1 in a million case. And if that's the situation, I won't start with the max. I'll instead grab something like this. I'll grab this region in here and I'll say I know that the average was 4, but we have instances, 10% of the instances fall between 15 and 30 days. What's causing that? So instead of grabbing the absolute maximum, I grab a region of the high end of the tail and we drill down from there. As soon as we're done determining root cause on the high end, I then ask the same questions about the low end. All right, we know that the average is 4. Our data set shows this. But when we were interviewing subject matter experts, they told us about instances in which they could bypass a lot of the process steps or expedite. And they talked about situations where they could complete in as little as 1 day. And we see that happening occasionally in the data set itself. So if the average is 4 days, but we know that we can complete it in as little as 1 day, well, what's causing this? And then we start to drill down, continuing to drill down until we've nailed root cause. I think the beautiful thing about process variation analysis is that it forces the team into using and working with the data that they've collected to help isolate and identify root cause. Very straightforward technique. We can use it in handoffs, in cycle times. We can use it across multiple areas of the process. And if that's the case, if I know that I'm not just doing this on overall process performance, but there are 3 or 4 specific areas that we want to do PVA, I may introduce a worksheet template. And so let me share with you what that template looks like. What I'll do is I'll identify the largest or most painful step in the system or steps, and then we just systematically go through PVA activities like described earlier, looking at best and worst case scenarios and identify root causes from there. The technique is called process variation analysis. It's a great technique if you are dealing with processes that have a large amount of variation, processes in which we're trying to reduce or eliminate that variation.